Alright guys, so this is the holes in a graph. It can be kind of easy if you let it be, but it can also get a little confusing if you don't watch out. So first of all, it is an open point on the graph where the point xy, where x is found from what cancels after factoring, and y is found by substituting or subbing x into the new, or you could say the simplified equation, either one, the new or the simplified equation. And a quick example would be something like x squared minus 9x over x plus 3. Okay, and if you notice, when you factor this, x plus 3, x minus 3 over x plus 3, the x plus 3's, x plus 3's would cancel. So, in order to find the x value, you take what was canceled and you set it equal to 0. So since the x plus 3 was canceled, set it equal to 0 and solve. So your x value would be negative 3. Then you take your new equation, or the simplified one where this had canceled. You're left with this, and it says to sub x into the new equation. So if this is your value for x, negative 3 minus 3 would be negative 6. So the hole in the graph would be at negative 3, negative 6. All right, then the other thing that we haven't talked about is called a slant asymptote. Okay, and a slant asymptote is where the degree on the top is 1 degree bigger or higher than the degree on the bottom. And when you have this, you have a slant asymptote. Sometimes it's also called an oblique asymptote, but it's going to be in the form y equals mx plus b. And let me write that word in case you ever see it, an oblique asymptote. Okay, and you always want to use synthetic division. All right, sometimes you'll use long division, but in our case, most of the time you'll just use synthetic division. All right, so we have two examples we're going to go through real quick. On the first one, if you're doing synthetic division, remember you set the denominator equal to 0 and solve, and that gives you the part that goes in your little box. And then you take the coefficient of each one of these, so you just take the number out front and then the constant on the end. So I have 1, positive 1, and a negative 6. Bring down the 1, multiply, you have negative 2. Add those together, you get negative 1. Multiply, you get positive 2. And even though your answer is negative 4, when you do this, you just need the first two pieces. You don't need the remainder, so don't worry about that. So your answer will be y equals 1x, or just x, minus 1. And that would be your slant asymptote. All right, and then again to do the other one, again set it equal to 0 and solve. So you get x equals 3. So you use 3 in your box, and then 1, 7, and 12. Bring down the 1, multiply, add, that gives me 10. And even though this is 30, it really doesn't matter. Don't bother wasting your time. So your slant asymptote there would be y equals x plus 10. All right, then it says, what if you have this? Well, notice that this is not a linear like these were, to where I could use synthetic division. So if I can't use synthetic division, then I would be left with the choice to use long division. But we are not going to waste our time on that. All right, then increasing. You can tell when something's increasing and decreasing by always reading the graph from left to right. So you want to read increasing and decreasing. You want to read the x values from left to right. And remember that you can only use parentheses whenever you're doing increasing and decreasing. Alright, moving on to the first one. Alright, always, 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 of course, factor the top and the bottom. As you know from that page in your book, it says to factor first. And nothing cancels, so that right there tells me I don't have a whole. So you can just say none, mark it out, do whatever you want. So you have no whole. Good, good, good. Alright, then the first step would tell you to find the vertical asymptote by setting the denominator equal to 0 and solving. So x minus 3 equals 0, which means x equals positive 3. There's that answer. Alright, then they tell you to find the x-intercept by setting the numerators equal to 0. So x minus 2 equals 0. Solve that. It means x is 2, so your point is 2, 0. Then x plus 1 equals 0. Solve that. You get negative 1, so negative 1, 0. Remember, with your y-intercepts, you want to do the constant over the constant. So we're going to do negative 2 over negative 3. A negative and a negative make a positive, so I have 2 over 3 for that. Horizontal asymptote, is the top or the bottom bigger? Well, the top is bigger, so that automatically tells me that I do not have a horizontal asymptote. I'm going to have a slant. So let's come over here and do the work for that. So in my box, I've already solved this part, so my answer is 3 that goes in my box. And then up top, I have 1, negative 1, and negative 2. Bring down the 1, multiply, add. Again, remember, you don't care about your remainder. So your slant asymptote is y equals 1x, or just x, plus 2. Alright, I'm going to go through and graph these real quick. Could have done it as I went, but I didn't. Alright, my vertical asymptote is at x equals 3. So vertical, remember vertical is up and down. Vertical asymptote at x equals 3. Horizontal asymptote, there's not one. So slant asymptote. Remember, this is your y-intercept, so start at 2. Your slope is positive 1, so up 1 over 1. Alright, and then I can graph my intercepts. I have an intercept at 2, at negative 1, and at 2/3. So that would be about right there, not quite to the 2, but close. Alright, and then you can plug it in your calculator and get the rest of your points. And I've already worked some of those out, so let me list those right here on the edge for you. I'll pull this over so you can see. Alright, when I was doing my graph here, I got a little too fast for myself, so I made a couple of mistakes. So anyway, I just want to make sure that you can see this, so I'm going to switch pen colors for a second. But at negative 5, I'm at negative 3.5, so that actually puts my point about right here. So this little purple part right here is a little off. And then keep going up. So here would be my next point. At negative 2, it says it's negative 0.8, so that's real close to 1, but not quite there. And then at positive 1, it says my answer is 1. So that helps me kind of graph this one. Got all the points I can. And you want to pay close attention to the fact that this is the highest section right here. I'm going to go ahead and write to the side what point this is. That'll help us in a second when we're doing the increasing and the decreasing. Alright, and then the other part, remember, since you graphed here, your diagonal part should be all the way up here. So at positive 2, already got that one, sorry. So at 4, my answer is 10. And at 5, my answer is 9. And at 6, it's 9.3. So just a little bit up. And again, that is my lowest point. So let's help ourselves out on that one. That again was the 0.59. Okay. All right. Increasing and decreasing. Always reading the graph from this side to this side. Don't forget that. and you are increasing right here. And so since this is the negative infinity side of the graph, we're going to say we're increasing from negative infinity to this x value. And remember, this x value right here is 1. So 1. Then it starts decreasing. So I'm decreasing from 1 to, and it gets really close to this line, so we're going to put this number right here, which is 3. Then from here, it's also decreasing, but we had to skip over this, so we're going to say union 3. It's decreasing until I get to the x value of 5. Then it starts increasing again, union from 5 all the way across, which would be positive infinity, because remember this is the positive infinity x value side of your graph. All right, the domain and range. So domain and range is going to be from left to right. So since my graph keeps going from this way on and on forever and ever, from negative infinity to, then it has to make a jump, so we have to show that. There's a discontinuity part in the graph where the graph is not continuous because of this dotted line here, the asymptote. All right, and then it picks back up from 3 and it goes on and on forever to the right. Then the range is the lowest it goes. Well, notice my arrow right here, so I'm going down forever and ever. But the highest my graph goes in this section is 1, 1 is actually what that should say, not 1, 0. 1, 1, yeah. Okay, so the highest y value it touches right here is that. Then it jumps, and the lowest y value here is 9, so then it goes from 9 up to infinity. And domain and range is probably the biggest issue that you're going to see from time to time whenever you have graphs that separate like this. All right, moving on to problem number 2. Might not have quite enough time to get all of this one in. All right, let's see here. So a vertical asymptote, again, set the denominator equal to 0 and solve. Your answer would be -2. So x equals -2. I'm going to go ahead and graph that. Then x-intercept, oh, bad child. I should have factored the top first. Luckily, nothing cancels, so you do not have a hole. So none for here. Alright, so moving on to the x-intercept, set the numerator equal to 0. Well, if I set this equal to 0 and solve, I would get -5, 0, and I would get +3, 0. Alright, y-intercepts, look back at the original. That would be -15 over 2. So 0, -15 over 2. And then for my horizontal asymptote, the top is bigger, so my answer is none. However, it is a slant asymptote, so I need to come down here and do synthetic division. Alright, I've already got the 2 that goes in my box. Remember, that was from your denominator. It should be -2, sorry. And then 1 to -15. Bring down the 1. Multiply, you get -2. Add, you get 0. Don't care about our remainder. So y equals 0. Or y equals x plus 0. So that makes our y-intercept 0. Go up 1 over 1 for your slope. All right, and then again, pull out your calculator and start graphing some points. All right, and I'm going to go ahead and show this one since I'm kind of running out of time. But if you're graphing your points, it's going to look like this. All right, and so that means your increasing is going to go from this side, -infinity, all the way up until you get to here, which would be the -2, which is what you see here. Then it increases again on this side. So it started increasing right after it passed the -2, so -2 to infinity. It's never decreasing, remember, because you always read your graph from this side to this side. The domain is everything except for the -2, and the range from the bottom to the top, it keeps going, so all real numbers.